What if I told you one of the most sophisticated, most expensive, most vital vehicles NASA has ever built can be worn by a single person? It costs over $12 million, and yet we don't call it a rocket or a satellite, we call it a spacesuit. That number might sound unbelievable for what looks like a futuristic snowsuit, but it's the honest truth. The reason for that staggering price is simple yet profound. A spacesuit isn't just clothing. It's a self-contained, human-shaped spacecraft designed to keep an astronaut alive in the most hostile environment known to humanity, the vacuum of space. It's your own personal world, complete with everything you need to survive where nothing else can. Imagine stepping outside your front door into a place that is simultaneously a burning furnace and a deep freezer. A place with no air to breathe, no pressure to hold your body together, invisible radiation, tiny, bullet-fast debris. That is the reality just a few hundred kilometers above our heads. Let's break down this wearable spaceship piece by piece. The helmet is your window to the universe, but it's far more than a simple bubble. It's composed of super strong polycarbonate and includes a protective visor assembly. This assembly has a special gold coating which is incredibly effective at reflecting the sun's harmful ultraviolet and infrared rays, protecting an astronaut's vision from the unfiltered, blinding intensity of direct sunlight in space. Inside, there's a vent pad to direct oxygen flow over the visor to prevent fogging and a small block of foam called the Valsalva device, which an astronaut can use to block their nose and equalize pressure in their ears, just like you might do on an airplane. The gloves are arguably the most complex and most challenging part of the suit to design. They need to be strong enough to withstand the vacuum of space and protect from extreme temperatures, yet flexible enough to allow an astronaut to grip tools, turn bolts, and operate equipment. The gloves have custom-molded fingertips and internal heaters to keep an astronaut's hands warm. Despite all this technology, they are stiff and cumbersome, and working in them for hours is physically exhausting. It's like trying to perform delicate surgery while wearing the thickest winter mittens you can imagine. So, if these suits are $12 million custom-built marvels of engineering, why do they still fail? The answer is a mix of age complexity, the harsh reality of their working environment. The core design of the EMUs currently used on the International Space Station dates back to the space shuttle era, the 1970s and 1980s. While upgraded and refurbished over the decades, they are fundamentally old machines. Like any aging vehicle, parts wear out, seals degrade, fabrics fray, electronic components can fail. The suits were only designed for a 15-year lifespan, and they have far exceeded that. The sheer complexity of the suit is also a source of potential failure. With hundreds of individual parts, connections, seals, electronic systems, there are countless potential points of failure. A tiny tear in a glove, a malfunctioning valve in the life support system, or a crack in the helmet's visor could have catastrophic consequences. To understand just how serious a suit failure can be, look at the harrowing experience of ESA astronaut Luca Parmitano in July 2013. He'd just started a routine spacewalk outside the ISS when he felt a strange wetness on the back of his neck. At first he thought it was sweat, but the water kept growing. Soon water was getting into his eyes, into his nose, into his ears. In microgravity, the water didn't just trickle, it clung to his face as a growing blob, making it impossible to see or hear clearly. The source was a mystery, but his personal spaceship was flooding. Water was coming from the suit's cooling system, a catastrophic internal leak. The close call with Luca Parmitano's suit, along with the ongoing challenges of fit and maintenance, has, really accelerated the push for a new generation of spacesuits. NASA is now looking toward the future of human exploration, to the moon with the Artemis program and eventually to Mars. These missions will require suits that are far more capable than the current EMUs. Astronauts won't just be floating in zero gravity, they'll be walking, kneeling, and digging on a planetary surface. This demands a suit with far greater mobility, flexibility, and durability than ever before. The future of spacewalks depends on this evolution. To meet this challenge, private companies like Axiom Space and Collins Aerospace are developing the next generation of suits under contract with NASA. The goal is to create suits that are not only safer but also more user-friendly. One of the biggest priorities is improving mobility. Instead of the bulky, balloon-like pressure garments of the past, new designs incorporate advanced bearings and flexible joints in the waist, hips, knees, and ankles. This will allow astronauts to walk more naturally, bend down to pick up rocks, and perform complex tasks that are nearly impossible in the current suits. The aim is to move from a suit you wear to a suit that moves with you. Subscribe to our Universal Universe channel for daily cosmic adventures. And don't forget to share and like the video as we continue exploring the incredible engineering that makes human space exploration possible.